Good day everyone, we are Group 1 and today we'll be discussing an important tool used in project planning scheduling, the Critical Path Method or CPM. Before we dive deeper in our diagram presentation, let's first take a look at the learning outcomes of our presentation. First, understand what critical path method and why matters in project management. 2. Identify the sequence of critical path method. 3. Apply the concept management project schedules more effectively. And now, let's understand what critical path is. A project management technique that identified the longest sequence of tasks, the critical path, that must be completed on a time finish a project within its scheduled time frame. And also, if any task on a critical path is delayed, the whole project will be delayed. That's why it is important to carefully plan, monitor, and manage these activities. After knowing what critical path is, we should also know what is the importance of critical path method. It determines the shortest possible duration to complete the project. Any delay in a critical task will be delayed the whole project. Helps project managers prioritize and allocate resources efficiently. And now, after knowing the meaning and the importance of critical path method, we should proceed in a sample diagram.
Let's construct the flow of the given activities. Since activity A has no predecessor, it will be our starting point of the flow. To start, activity B needs activity A, activity C needs activity B, while activity D, E, and I requires activity C to be completed. Activity G depends on activity D, and activity F needs activity E. Activity H connected to activity E and G, while activity J needed activity F and I. Next, activity K and L needs activity J to be completed. On the other side, activity M requires activity H, while the N needed activity K and L. And lastly, activity M and N has no successors. It will directly go into finish. We will be using this node convention here, which A stands for activity and T stands for time. ES is the earliest start where the activity can start, and EF is the earliest finish time. LS is the latest start time, and LF is the latest finish time. This table outlines the critical path method or CPM for a construction project, detailing each activity from start to finish. It includes the activity descriptions, their predecessors, estimated durations, and key scheduling values such as early start, early finish, late start, late finish, and slack. All activities listed have zero slack, meaning each one lies on the critical path. This means any delay in this task will directly delay the entire project. The total duration of the project is 52 days, ending with landscaping. From site clearing to landscaping, this plan ensures a smooth workflow, allowing for efficient monitoring and timely completion of the construction project. We will proceed to the actual project network, where we're going to apply the convention method. Let's start with the forward pass. Since activity A has no predecessor, the earliest time will be 0, so we can compute the earliest finish time using the formula. Earliest finish is equals to earliest start plus time. By applying the values from the given data, we will start to compute the forward pass. Since the estimated time for activity A is 3, it means 3 plus 0 is equals to 3, and we will just continue the process. Next is activity B that needs activity A to be completed before it can start. Since the earliest start for A is 3, then the earliest time for activity B is 3, So 3 plus 5 is 8. For activity C, 8 plus 11 is equals to 19. On the other hand, activities D, E, and I are connected to activity C, so their earliest start is 19. First is the activity D. 6 plus 19 is 25. For activity E, 5 plus 19 is equals to 24. While in activity I, 7 plus 19 is 26. To continue, activity F has 24. So 24 plus 6 is 30. Activity G requires activity D that has 25 as the earliest finish time. 25 plus 7 is 32. Activity H needs activity E and G. Since we're talking about forward pass, we will have the highest number, which is 32. The earliest start for activity H is 32, so 32 plus 9 is 41. For activity M, 41 plus 2 is 43. On the other side, the earliest time for activity J is 30, so 30 plus 9 is 39. Activity K and L needs activity J, so they'll have the same earliest start, which is 39. For activity K, 39 plus 4 is 43. While activity L, 39 plus 6 is equals to 45. Activity N needs activity K and L. Since 45 is the highest value, we will use this as the earliest start for activity N. So, 45 plus 7 is 52. The project's completion time is 52 days because the highest earliest finish time between activity M and N is 52. Now, after completing the forward pass and identifying the earliest finish time of the project, which is 52 days, we will proceed to backward pass. Since the project completion time is 52 days, the latest finish time for the activities or the finished activity M and N has to be 52. In order to identify this, we can use the formula for backward pass, which is latest start is equals to latest finish minus time. So the latest finish for activity N is 52. 52 minus 7 is 45. 45 is earliest finish time. For activity M, 52 minus 2 is 50. Meanwhile, activity K and L will get the latest start of activity N, which is 45 as their latest finish time. So for activity K, 45 minus 4 is 41. While 45 minus 6 is equals to 39 for activity L. Since activity J requires activity K and L, and we are talking about backward pass, we will have the lowest value, which is 39. For activity J, 39 minus 9 is 30. Activity F and I are connected to activity J, so they'll have the same latest finish time, which is 30. For activity F, 30 minus 6 is 24. And for activity I, 30 minus 7 is 23. On the upper side, the latest finish time for activity H is 50. 50 minus 9 is 41. For activity G, 41 minus 7 is 34. While activity D, 34 minus 6 is 28. Activity E requires both activity F and H, and the lowest value is 24. So for activity E, 24 minus 5 is 19. The lowest value between activity D, E, and I is 19. So this will be the latest finish for activity C. So 19 minus 11 is 8. For activity B, 8 minus 5 is 3. And lastly, the latest finish for activity A is 3. So 3 minus 3 is 0. The backward pass is completed. Now, the slack for an activity is defined as how long the activity can be delayed without extending and increasing the project's completion time. And it is calculated as slack is equals to latest start minus earliest start, or latest finish minus earliest finish. The slack for A would be 0 minus 0, or 3 minus 3, which will be 0. The slack for B and C will both be 0. For activity D will be 9. For E and F are also 0. The slack for G and H will be 9. And for activity I will be 4. For J will be 0. And for K will be 4. For activity L, still on 0. And for M will be 9. And lastly, activity N is 0, which means those activities with 0 slack cannot be delayed. The activities with 0 slack are called critical activities, while those activities that have above 0 value will have time to be delayed, but the project will still be completed within 52 days. So to sum it all up, our critical path are A, B, C, E, F, J, L, and N.
And now, let's move on to the standard deviation computation for critical path method. This image represents the use of standard normal distribution in PERT analysis within a critical path method. We estimate the probability of completing a project within a certain time. The z-score helps to calculate this probability by comparing the target project duration during the expected time and standard deviation. The shaded area between z is equal to 0 and z is equal to 1.79 shows there's a 36.32% chance of project will be finished within that time range. Before we end our presentation of critical path method, let's go over some key takeaways from what we discussed. First, CPM identifies the longest sequence of tasks that determine the project duration. Second, is help in prioritizing critical tasks to avoid delays. Third, understand how critical path method diagram works. And for the last, standard deviation show a possible time variations and risk. These key takeaways summarize the most important points from our discussion on critical path method. And I hope you learned a lot from this video.